In this video, I explain encapsulation in object-oriented programming. After watching this video, you are able to describe what private attributes and properties are. You can distinguish between a property and a getter or setter method, and you can explain why we use properties and private attributes. My assumption is that you already know the difference between a class and an object. You know why we use classes. You're familiar with attributes and methods in a class. You know what an initializer, a donder init does in a class. You're familiar with special methods such as donder str and donder add. You know how to create a class and you know how to use a class. If you have problems with these concepts, please watch the previous videos. Let's do this exercise quickly so that we are sure that you have the prerequisite knowledge. In this exercise, we have a class called test. It has one attribute called x, which is set to 1 when an instance is created. And there is another method called getX, which returns the value of the attribute x. And then we have some codes. We would like to know what is the result of running this code in the main section. Let's go over the answer quickly. So the first line is t equal to capital T test. That creates an instance of the class test and calls names it as t. This test, this line, it has a parenthesis after that, which means that the donder init method has to be executed. And you see that as a result of executing the donder init, an attribute called x is created and it is set to 1. If you try to execute the next line, printing t.x, as you can see here, the value of x is 1 and 1 is going to be printed. However, you can also call the method for this class getX. So if you call this method getX for t, since x is equal to 1, what is going to be printed is again 1 here. You can also change the value of the attribute using, by setting it to a value. In this case, we set it to 5. So as a result, you can see that the instance t has a new value 5 in its x. So this time, if you try to print t.x or t.getx, the result would be 5. So now we can learn what encapsulation is. We would like to know why the front-end programmers love classes. So you need to know that classes are like coffee machines. You don't need to know the details. You don't need to know how the coffee machine is working internally to create espresso, to make espresso or cappuccino for you. So you don't need about the details. You just press a button and everything works. So what you need to do is you simply press a button and then you're done. So this lovely feature is known as encapsulation. That means you don't know what is going inside the machine. You just need to know how to use the machine. So the details are hidden from you. Encapsulation is built upon private attributes and methods. So we need to learn what a private attribute is to be able to understand what encapsulation is and why it's going to be so useful to us. So what is a private attribute? So far, we have only learned about public attributes. Public attributes are those attributes that you can have access to them in the donder main section of the code. So in this case, for example, the class test has a public attribute called x, which is set to 1 here, and the Donder main section of the code can have access to this X and set it or change it or even read it, as you can see in the second line of the Donder main part, where we try to use print to print this X. Private attributes, however, are not accessible in the Donder main part. We show them in the class using two underscores. So a double underscore before the name of an attribute or even a method means that that attribute, that method is a private attribute. Note that you should not have another two underscores after the name of the private attribute. Otherwise, it's going to be dealt with differently. So this self dot under two underscores y is a private attribute. I'm going to call it private y from now on. And this private y cannot be accessed in the main section of the code. Only the methods inside that class can have access to that X. In fact, only the methods of that instance of the class can have access to private Y. So, as I said, the Donder main part, the American programmer, the front-end programmer, does not have an easy way to access the private Y. So if you try to read Donder private Y, if you try to have access to private Y in the Donder main section, it's Python is going to show you an attribute error and showing that this test class does not even have an attribute private Y. So it's as if we are not aware of the existence of this attribute, and that's the meaning of encapsulation. We don't see what's going on behind the scene. So as I mentioned, private Y is not accessible to the Donder main part and anything outside the class, and that includes other instances of that class as well. You can see here we have two instances of the class test here, T and P. T and P can have access to one another's X because X is a public attribute, but they do not have access to each other's private Y. And in this case, as you can see, Y is added, is placed inside the class, not on the border of class, to show that this is a private attribute. But what we know that get X and get Y of that instance of the class can have access to private Y. But so in this case, the get X of T can have access to its private Y, but get X of P cannot have access to the private Y of T. I said that we cannot have access to private attributes, but the correct way to put is that we don't have an easy way to access to private attributes. If you really want to have access to private attributes of an instance, you need to write down the name of the instance. As you can see in the last line on the left side, you need to provide the name of that instance, which is T in this case, then put a dot, then put one underscore and the name of the class. And after that, provide the name of the private attributes. This is a way to have access to the private attributes. So pause here for a minute and try to do this exercise to ensure that you learn private attribute. So the first two lines of the Donder main section we'll create an instance of the class test and call it T, and then it set the attribute of X, the attribute X of T to 45. So if you print T dot X, 45 is going to be printed. In the third line, you see that I try to directly set the private attribute Y to 45. We know that we don't have access to private Y, but Python will think that you try to create a dynamic attribute, an attribute that is going to be created only for this instance of T, and other instances of test are not going to have it. So this donder Y that is going to be created is going to be a public dynamic attribute of that instance of T. So when you try to print T dot underscore to underscore Y, because you don't have access to the private attribute, which is 1 in this case, Python thinks that you are trying to have access to a dynamic attribute, which is 45 at this moment, and that is going to be printed. So if you use getY, if you try to call getY, the method getY for the instance T, getY, the method, is not going to be aware of the dynamic attributes. So they usually look for the private attribute. This getY looks for the private attribute, which is private Y. And as you can see here, it returns that private attribute, which is 1, and 1 is going to be printed. If you want to have access to the private Y attribute, as we mentioned, you need to use the name of the class and then the name of the private attribute to have access to it. But why do we need private attributes? Look at this case. We have a class called CLS simple fraction, and this class has two attributes, numerator and denominator, called as n and d respectively. And you can see here that in the Donder main section, the American programmer, the front-end programmer, can simply create an instance of this class, giving 3 and 0, 3 for the numerator and 0 for the denominator. And we know that, the denominator of a fraction cannot be 0. So here you can see that when we have a public attribute, we cannot have control on what is given as for the inputs to the attributes. We cannot have control on setting the attribute. The American programmer can give anything he wants to the attribute. He can set it to whatever values he wants. But we should not allow that, because that's not, the way the fraction class we would like to work. So what we do, we make all those public attributes private so that we can have control access to them using methods. So you can see here that I have two methods, setD and getD, on the right side, and I'm going to use setD and getD to read and set the private attribute of D. So the private D is going to be set by setD, and if I want to read it, I use getD to read it. So you can see here that we use private attributes and the setter and getter methods for data validation. We do not allow the front-end programmer to set the denominator to 0. If that happens, we raise an exception. We can also use these two methods for data adjustment. That means if 2 over 4 is given as a fraction, we can simplify them when we try to set the private attributes. So you can see here that I turned N and D, the two attributes, to private attributes by adding two underscores before their names. And in the initializer method, If the front-end programmer tries to provide a denominator of 0, I'm going to raise an exception, and that means that the front-end programmers will end. Uh, of course, we also need to allow the uh, front-end programmer to change D and N if he wants to. I have created a setter method. I called it setD. As you can see, again, if the denominator is 0, I'm going to raise an exception. If it's not 0, I'm going to set private D to the given denominator. We also need to have a method called getD, a getter method that will return the denominator, the private D. However, what we require here is that we want that instance of the class of fraction to be simplified before returning the D. So what I'm going to do is I'm going to uh, create a private attribute called simplify, which simplifies the fraction. If you don't remember how we did that, please watch the previous videos. And then I'm going to call this private method inside the getter function, simplify the fraction, changing private n and private d, and then return self dot private d. So I have made simplify a private method because the user does not need to know about this private method. Let me emphasize, one thing that we already learned about in the previous lectures here. You can see that the private simplify function only gets, one parameter, which is self, and you don't see that it gets, two variables, of, to the numerator and the denominator of the fraction. And that's because it doesn't require those two parameters of n and d. And the reason is that it already has access to them through self. We learned that a class is a bundle of variables and methods. So the private simplify function can already have access to private n and private d using the self variable. So now if you try to use this fraction class, a CLS fraction class, to create an instance called f1 giving two values 4 and 6, you can see that behind the scene two private attributes, private n and private d, are created and are set to 4 and 6 respectively. If you try to print f1.getD, you can see that behind you would see that behind the scene the private simplify function is executed and turns d and n to 3 and 2. So as a result, if you when the print function is executed, a 3 is going to be printed. If the user, the American user, the front-end programmer, try to set d to 0, the method setD knows that 0 is not acceptable and it creates an exception. For example, denominator cannot be 0 and it ends the program with an error. Now let's do an exercise. Pause here for a minute and write the getter and setter method for the numerator. We haven't written that part. So you need to create a setter and a getter. I'm going to call the setter set n, and it gets two arguments, two parameters. The first one is always self, and the second one is numerator equal to 0. That means if a numerator is not given, I'm going to assume that private n should be set to 0. And you can see here I don't need any validation because numerator can be anything. So I simply write down self.private n equal to numerator, the argument. We also need to add a getter method for private n. I'm going to call it get n. It only requires one argument self, and we don't need anything else. Here in this case, I need data adjustment. That means I need to simplify the fraction before returning n to the front-end programmer. So that's what I'm going to do. I use self.private simplify, and then I return self.private n. Let's do another exercise. Pause here for 2 or 3 minutes and try to add a donderstr method. We want the donderstr method to simplify the class and print it, simplify the fraction and print it in a good manner. So for example, if f1 is 4 over 12, 1 over 3, 1 for slash 3 should be printed. If the fraction is 4 over 1, only 4 should be printed. How can you do this? So here's the answer. Uh, First of all, before returning anything, I need to make sure that the fraction is simplified. That's why I'm going to call the private simplify method to do data adjustment. If the denominator is 1, I only need to return the numerator, the private numerator. That's what I do here. And if the denominator is not 1, then we need to return the class as we did in the previous examples, in the previous videos. So now that we learned about private attributes and methods that set them and get them, called setter and getters, we can learn about property. So you need to know that sometimes the American may not like to use brackets, the parentheses, to set or get a private D. So he doesn't like brackets, but he just wants to use simple D and N to do that. But behind the scene, we need to be able to do data adjustment and data validation. So that's why properties are created. Uh, you just don't like to write down f1 dot set d and in parentheses 3. You would like to write down f1 dot d equal to 3. You don't like to write down f1 dot get d parentheses and set the value to and use the value to set I. You just want to simply write down f1.d. So for these cases, if the American says that I don't like it, but I need data adjustment, I need data validation behind the scene, then you use properties. So property is a setter or getter without parentheses. So how can we create a property? First, we learn how to create a getter property. You need to use the decorator @sign property for that. So if you're asked to create a getter property for a private variable, for example, private D, first you need to write down the getter method. So you see, we have written the getter method. Then you only need to change the signature of the getter method uh, by uh, simply giving it the name and adding @sign property decorator right before the def keyword in the previous line. So that's how you create a getter property. How can you create a setter property? You just need to use another decorator. You start with @sign, then the name of the property, and then the keyword dot setter. So if you're asked to create a setter property, first you create a setter method, as you learned in the previous slides. Then you change the signature of the method, the first line, to simply to be the same thing. You change the name of the method to be only having the name that the American programmer specified, which is D, and then right before that line, you add the decorator @ sign, the name of the property, which is D, and then dot setter. So it's very simple. Whenever you ask to write a property, what you need to do is to just create the setter and getter and then turn them into a property using the decorators. Let's do this exercise. We have this get n and set n in the CLS fraction. I would like you to add a property n here. That's how you can do this. So you simply turn get n to def n, and you put that sign property right before that. As for set n, you just turn that to def n, and you put @ sign n dot setter right behind it. So it's as simple as that. Let's do another exercise to ensure that you learn the properties well enough. This time, I would like to remember the class point where we had two attributes of x and y and a method distance from origin. I would like you to add a read-only property called distance. When I say read-only property, I mean you only need to write down the getter property, not the setter property. Read-only getter property. So the American wants the code to look like this. The property is like that. You would call p1.distance. There is no parenthesis after that. That's how you know this is a property, but you know that behind the scenes some sort of calculation must be done so that could be set to the value provided by the distance. How can you do this? So here's the answer. We already had the method distance from origin here. This is a method. It requires parentheses to be called by the front-end programmer, the American. I only need to turn this into a property. So that's why what I did. The American wants the name to be distance with capital D. So I changed the name to distance, and I simply add a decorator @ sign property right before this line, and that's how this property is created. So always try to write the getter or setter method first and then turn them to properties. So in the exam, I always give you the American's view of the code, what the front-end programmers want. So in this case, you can see that I would like to have a class called CLS fraction that can get two values, 3 and 8, to create an instance called f1. Then I provide f1.n equal to 4 and f1.d equal to 5. From this, you cannot figure out if n is a public attribute or a property. So your assumption in the exam should be that it's always a public attribute, because you need to be as fast as possible during the exam. However, if in the text of the code I ask you to resolve problems, for example, validation problems or adjustment problems, then you have to use a property here. So this is the difference between having a private attribute with property and a public attribute without any properties. You can see that here we have a private D on the left and a public D on the right. So the great thing about public attributes is that you need less coding, as is completely obvious here, and it's faster. It's a good choice during the program, unless you are told to do data validation and data adjustment. The issue with public attribute is that there is no data validation. You cannot raise exception if D is set to 0 by the front-end programmer. You can not do data adjustment either. You cannot do simplify when the American asks for D to be retrieved and printed to be shown to the user, for example. So let me provide a summary of encapsulation, what we have learned so far. We have learned that we have private attributes and private methods. Private attributes is like, not putting the storage of your factory on the border, so that the American does not have access, direct access to Dutch storages. Uh, we do that so that we can add properties that act like a port. These port will have customs and they don't allow anything invalid to be stored in Dutch territory. So we check the values import. If something goes wrong, if the values are against the validation rules, then we raise an exception. But know that you can always put your storage on the border and not you can go for not using ports. Python doesn't mind, it's just bad programming. Uh, Again, during the exam, you are not, uh, you are not required to use public to use properties. You can go for public attributes. We also learn about private attributes because the way that we do inside the class, the way that we behave inside class is our business. The American does not need to know about the simplify function or even the GCD function. Those methods are, are for us. We are not going to share them with the American. Also, the American, the main program or the front-end programmer and other instances do not have access to these private methods. Keep that in mind. If you have any question, I'll answer them during the interactive lecture session. In the next class, we learn about using classes to manage files.